Trigonometric, Graphing Trigonometric Functions 2, Video 1. So this is Lesson 3 in Unit 9. And let's go over a few things. So we have parent functions of trigonometric functions, which would be your sine, cosine, tangent. And then we have the secondary or reciprocal functions, which we'll talk about in a different video during this lesson, which would be cosecant, secant, and cotangent. Both sine and cosine, one cycle length for the parent function is 2 pi. So to complete the 4 steps is a length of 2 pi. But for tangent, to complete the 4 steps, it's going to be a length of only pi. So one cycle is a length of pi. As a reminder, tangent is equal to sine divided by cosine. And in the previous video we watched, we talked about the shortcut method in order for you to be able to identify the ordered pairs around the unit circle, and that's going to come in handy today. All trigonometric graphs occur in 4 units, or I often say 4 steps. Let's get started. So the first thing I'm going to do is let's look at this first example. The parent function y equals the tangent of x, and recall that those 4 steps to complete this cycle will be done in a length of pi. So when we worked with sine and with cosine, I would ask you to take 2 pi and divide it by the b value. Well, the b value here is 1. But with tangent, because the 4 steps are completed in a length or interval of pi, we're only going to divide pi by whatever the b value is. And here, the b value is 1. So I have a period length of simply pi for this parent function. As I've stated in this video, both sine, cosine, tangent all have the 4 steps or 4 units to complete a cycle. So I can take and divide by 4. The amplitude here is the exact same. It has an amplitude of 1. I'm going to begin by marking off the units to the left and right of the origin. Okay, let's get started. So I'm going to start here on the first step here. When I'm here at 0, this would be 0. And when I take the sine and divide it by the cosine, 0 divided by 1 is 0. So at this position, I can mark a 0. Let's go to pi over 4. So at pi over 4, here's pi over 4, also known as 45 degrees. When I take the sine and divide it by the cosine, notice they're the exact same values. Just like if you took 3 divided by 3, 5 divided by 5, x divided by x. When you take the same quantity and divide it by itself, it simplifies to 1. So this, at pi over 4, we have a value of 1. Now let's go up to pi over 2, also known as 90 degrees. When I take sine and divide it by cosine, I have 1 divided by 0. Remember, you can never have 0 on the bottom of a fraction. When that happens, it's referred to as being undefined. And undefined on a graph can be seen as a vertical asymptote. Let's move on to 3 pi over 4. Here's 3 pi over 4. So notice I'm going in 45-degree increments. 3 pi over 4, I want to take the sine and divide it by the cosine. So I have the exact same values, but their signs are different. So when I take pi divided by 2 and I divide it by a negative pi divided by 2, I'm able to simplify that simply to get a negative 1. Instead of being a positive 1 because of different signs, it would be a negative 1. So at 3 pi over 2, I'm going to drop down to negative 1. At pi, or 180 degrees, when I take sine and divide it by cosine, 0 divided by negative 1 is simply 0. At 5 pi over 4, which is down below in the third quadrant, we have the exact same values with the exact same signs. And so when I divide them and simplify, I end up with a positive 1. 5 pi over 4 is at positive 1. Now at 3 pi over 2, down here at 270 degrees, taking sine and dividing it by cosine, negative 1 divided by 0 again results in it being undefined. And on a graph, we illustrate that with a vertical asymptote. All right, let's move on. Remember, our functions will never cross or intersect a vertical asymptote. 7 pi over 4 is over here. We have the exact same values, but they're different signs. And so when we take sine and divide it by cosine, we end up with a negative 1. And we finish this one cycle here, going all the way, one cycle around, and we have 0 divided by 1. So 0 divided by 1 is 0. Okay, so what does this look like? Remember how asymptotes work. You're going to get closer and closer to that asymptote. So it comes up, then it gets closer and closer. And we can see it's doing the exact same thing over and over again. So we're able to take and follow this cycle. Notice there's 4 steps, 1, 2, 3, 4. So let's go 4 the other way. 1, 2, 3, 4. And we can see the pattern. We can see the pattern of how this runs. It gets closer and closer, comes in and down. Exact same thing here. We're going to be up here at 1. It's going to get closer and closer and come in. All right, so in this particular graph, I've gone out all the way here 2 cycles to the right, which is a distance of 2 pi, and 1 cycle to the left, which is a distance of negative pi. We have an amplitude of 1, and I've identified the period and the x scale. Let's apply it to the second. Looking at example number 2, y equals 4, tangent of x, the only difference I see between example 1 and example 2 is the value in front of the x, referred to as the amplitude, has changed from a 1 to a 4. So let's get started here. Remember, I'm going to take, to figure out the period, I'm going to take pi, and I'm going to divide it. I'm taking pi and dividing it by the value directly in front of the x, called the b value, so I end up with pi. And then to get the x scale, just like sine and cosine, we have 4 steps, taking pi and dividing by 4. So I'm going to look up above here, and I'm going to copy this down. I'll be right back with you. And actually, I can even show you in here how I'm doing this. So I'm going all 45s. This is pi over 4, 45 pi over 2, 3 pi over 4, 1 pi, 5 pi over 4, 3 pi over 2, 7 pi, and all the way to 8 pi over 4, also known as 2 pi. And that's what I'm going to write down at this time. Okay, so you may be thinking, do I need to worry about shifting this up or down, a vertical shift? Because we see no value behind the tangent of x, I at this time know that my midline remains at y equals 0. Okay, so I'm going to take this, bring it back over here, and we're going to use this as I go around. Okay, at 0, when I take and go with the sine divided by the cosine. Sine divided by cosine. So 0 divided by 1 is simply 0. Let's go pi over 4. Oh, I forgot to do one more thing. I did get an answer of 0. This is true, but I need to make sure to multiply it by the value up front. Now, the last problem is a 1, so it didn't change anything. The amplitude remained 1. Let's do the next part. So at pi over 4, I have radical 2 over 2 divided by radical 2 over 2. Again, the exact same value, so I end up with 1. But I do need to multiply it then by the 4. So I've evaluated the tangent at 45 degrees, or pi over 4, and I received an answer of 1, but now I need to take it times the value out front to receive the output. And so the output becomes 4. So at this position, we're up to 4. Now at pi over 2, I have 1 divided by 0. Well, 1 divided by 0, as we spoke about in the previous, is undefined. I don't need to take it times a 4. It's still undefined. Let's go with 3 pi over 4. So 3 pi over 4 is right here. We have the exact same values. I'm dividing them, but they are different signs. So I end up with the negative 1. Negative 1 times 4 is negative 4. All the way down here, negative 4. Let's jump over to pi, or 180 degrees. Sine divided by cosine, 0 divided by negative 1 is 0. And taking 0 times 4 is still 0. And you can see this pattern here. Once you catch on to the pattern, you can just continue it. Let's do one more. 5 pi over 4 here. So I have the exact same values. A negative divided by a negative with the same value is a 1. But then I have to take it times 4. 1 times 4 is 4. And I'll do just one more so it becomes better clarity for some that may be struggling here. At 3 pi over 2, I have negative 1 divided by 0. That's undefined. Can't have 0 in the denominator. I don't need to worry about taking undefined and multiplying it by 4. It's still undefined. So this gives me enough clarity to see what's happening. So you can see that it's rising at a much faster rate, right? It's coming in here, and it's rising at a much faster rate. So down here we'll be at -4, and then we'll have another vertical asymptote at -pi/2. This will be up here at 4 and at 0. So it's going up like this and down quickly. And over here we're just following the exact same pattern. It's going to be at -4 and at 0. All right, I've got out a distance of 2 pi to the right as a maximum and -pi as a minimum for this particular graph. Let's look at example. Example number 3 could easily be confused with example 2. So example 2 was y equals 4 tangent of x, but this time instead of having the 4 in front of the tangent, it's actually going to be behind in that b value. So let's start by finding out what is the period length. I'm going to take pi and divide it by the value directly in front of the x, which is 4. So my period length is pi/4. That means after 4 to the right, 1, 2, 3, 4, I will be at pi/4. Now, how do I figure out the x scale? I'm going to take this value, and it's always 4 steps, and divide it by 4. So pi/4, turn division into multiplying, and flip this. My apologies, my kids are just arguing. Okay, so I'm going to take our period length and divide it by 4 to get pi/16. So pi/16. Now, as I showed you with sine and cosine, don't stress about this. We're going to grab the calculator, make sure you can see it here, and I'm doing 1/16, forget about the pi. And I'm going to continue to add 1/16, hitting math fraction, enter, enter, just to be able to reduce it. To this, I'm going to add 1/16, and I'll show you how we can see if we are doing it correctly in just one extra step. When I add 1/16 here, I better end up with pi/4 because one cycle or 4 steps, 4 units, should equal the length of this period. And we can see it does. So I'm going to press pause. I'm going to do 4 more steps to the right and then the 4 steps. All right, for this particular function, we can see we have an amplitude of 1, just like we did for our first example. Let's get started. So I'm going to grab my unit circle, and here's where we have a little trouble. We know the basic shape of this, right? We know the basic shape of this. We know that by the time we get to pi/4, we know that we should be done with one cycle and what it looks like. So it's going to be important that we think back to what the previous shapes looked like. So when I look here, I'm going to go to pi/4 because these other ones, they exist, but they're not on this unit circle. We couldn't put everything on. So let's find pi/4, and let's figure out what is the tangent. So pi/4, let's evaluate what is the tangent at this position. Okay, so what I've done at this point is I've taken what the function is and I wrote it down. So we have that imaginary 1 that's in front of the tangent representing an amplitude of 1. And then I have the tangent of 4 times, and I'm going to plug in each one of these steps or units as we move to the right. So when I plug in pi/4, let's evaluate this, and let's use that unit circle to assist us. Let me find out where it went. Give me 1 second. There we go. So 4/16, I can rewrite that as the tangent. 4/16 reduces to 1/4. So pi/4, and then I'm going to take it times 1. So I'm going to find out where is pi/4. It's at this position. Now, what is the tangent at that position? Sine divided by cosine is 1, and 1 times 1 is 1. My kids are fighting again. Sorry, mom duties. All right, so we have the tangent of pi/4, which is right here. Sine divided by cosine, they're the exact same, so I end up with a 1. 1 times 1 is 1, and that's how I get this position. My output is 1, and so at this position, I plugged in this value. That was my input. My output is 1. Let's now go on to pi/8 as the input. So this is going to reduce to 1/2. So I really have the tangent of pi/2. So let's find pi/2, or 90 degrees. Sine divided by cosine. 1 divided by 0 is going to be undefined. This is undefined. And taking undefined by 1 is still undefined. So I'm going to come over to pi/8, and that's going to be undefined. Let's go to pi/16. The 4 on top and the 4 on the bottom are going to reduce to 1/4. So this is the same as 1 times the tangent of 3 pi/4. 1 times 3 is 3, all over 4. So at 3 pi over 4, let's find the tangent. Sine divided by cosine, the exact same values, but a positive divided by negative is a negative. This portion gives me -1. -1 times 1 is still -1. So I'm going to go on my graph. My output value there is at -1. Now at pi over 4, the 4's are going to be reduced to 1. And so I want to evaluate what is the tangent at pi. The tangent at pi, 0 divided by -1 is 0. 0 times 1 is going to be still 0. And we can see the exact same thing, right? And so with math, we often have patterns. And we can see, guess what this is going to be? Let's do one more, and then hopefully you catch on to the patterns. Catching on to patterns is going to save you a lot of time. So y equals 1 times the tangent of 4. You may be wondering, why is the 4 out front? As a reminder, see the 4 right here. That's why we chose that. And I'm going to do 5 pi over 16. 4 and the 16 reduced to 1 over 4. So really, I want to know what is the tangent of 5 pi over 4, and then I'll take it times the 1 out front. So 5 pi over 4 is at this position. They're the exact same values, so sine divided by cosine, exact same, will give me a 1. 1 times 1 is 1. And then you can see at this point what this is looking like, right? You can see what this is looking like. And so it is important that I have those dots. So this is going to be at -1 and 0. So it's going like this, getting closer and closer to the vertical asymptotes, but never actually touching them. And now here we go. This is y equals the tangent of 4x. I've done 2 cycles to the right, so I've gone all the way out to 1 pi over 2 for a maximum, and my minimum is negative pi over 4, or 1 cycle to the left. Let's get started with example number 4. So in example number 4, let's just take a look here. We have a primary trig function that's a tangent. I have a b value of 1/3. I have a negative value, so I wonder what that's going to change. Up to this point, we've seen this shape of our tangent function, right? Or it rises from left to right, if we want to think of it like that. And I have an amplitude of 2. Let's get started. First thing we're going to do is we're going to figure out what is the period length. So I'm taking pi, not 2 pi, as we use for sine and cosine, but taking pi, and I'm going to divide it by our b value, which is 1/3. And in doing so, I need to multiply by the reciprocal of 3 over 1, and I end up with a value of 3 pi. So my period length is 3 pi. That means after I go 4 steps, or 4 units, I will end at 3 pi. And by the way, if I'm doing 2 cycles, as I've done with all of the last lesson and this lesson, if I'm doing 2 cycles to the right, 3 pi and 3 pi will be 6 pi. Now let's figure out what will be the x scale. So I'm going to take that value of 3 pi and I'm going to divide it by 4. So this is going to be 3 pi over 4. And then I can grab my calculator, not having to stress about this, and take 3 over 4, forget about the pi at this point, plus 3 over 4, math fraction, enter, enter, and I have 3/2. Let's add a 3/4 to it again and simplify it to get 9 pi over 4. And you can see when I add this last time, when I take plus 3/4, I better end up with 3 pi. If I don't end up with 3 pi, it means I'm doing something wrong. I'm going to press pause at this time. I'm going to put in the next 3 steps to the right and then also to the left. All right, now we need to start to determine when I input in each of these steps or units to the right of the origin, how do I get an output value that represents that? So let's start right now with 3 pi over 4. I'm going to plug in 3 pi over 4, and let's see if there's a quicker way of doing this. 3 pi divided by 4, and I wanted to divide it by 3. So 3 pi over 4 times the reciprocal, which is 1 over 3. So if I am able to actually see that the 3's and the 3's will actually simply be reduced down to 1, I get pi over 4. So I want to know, what is the tangent of pi over 4? Notice how these two, I'm just simplifying. These are the two I'm simplifying, and it leaves it as pi over 4. I'm going to come up with and evaluate using my unit circle and then multiply it by the -2. So at pi over 4, I have a tangent, sine divided by cosine. They're the exact same values. So sine divided by cosine gives me 1. This is 1. 1 times -2 is -2. I plugged in 3 pi over 4, and I came up with an output value of -2. Let's do 3 pi over 2 and see if we can figure out a shortcut to this. So on top, I have 3 pi over 2, and then I'm going to divide it by 3. Now, why am I choosing 3 in the bottom? We can see if that's what we are provided. So 3 pi over 2, and again, I would write down divided by 3, and then I'm going to multiply it by the reciprocal. So what happens? I end up with pi over 2. I end up with pi over 2. Okay, so at pi over 2, let me bring this back here. At pi over 2, the sine divided by the cosine, well, 1 divided by 0 is undefined, and if I take undefined and multiply it by -2, I still get undefined. Let's do 9 pi over 4. So y equals, excuse me here, wrote that down, -2 times the tangent of 9 pi over 4, and then divided by 3. So 9 pi over 4, and then we're going to multiply it by the reciprocal, because dividing by 3 is multiplying by the reciprocal of 1/3. And the 9 and the 3 reduce. So the 9 and the 3 reduce to a 3 and a 1. So when I multiply, I get 3 pi over 4. So let's first do this. Let's first figure out what is a tangent at 3 pi over 4, and then I'll multiply it by the -2. Here's 3 pi over 4, and I want to know what is a tangent. Well, they're the exact same numbers, just different signs. So sine divided by cosine gives us a -1. -1 times -2. -1 times -2 is a +2. 1, 2. And hopefully you're soon going to start to see what this looks like. Let's do 3 pi. I'm going to come over here where it's easier for you to see. -2 times the tangent of 3 pi divided by 3. The 3's simplify to 1, and now at pi, sine divided by cosine, 0 divided by -1 is 0. 0 times -2 is 0. I'm going to do 2 more, and then I'm just going to continue the pattern. So 2 more algebraically. Y equals -2 times the tangent of 15 pi over 4, all divided by 3. So 15 pi over 4, and I would divide it by 3, but that's the same as multiplying by 1/3. The 15 and the 3 reduce down to 5 pi over 4. So 5 pi over 4 is right here. 5 pi over 4, what is the sine divided by the cosine, also known as the tangent? The exact same number, same sign, so I end up with 1. So this portion gives me 1, and 1 times -2 is -2. Last one I'm going to do algebraically. Let's find some room right over here. Y equals -2 times the tangent of 9 pi over 2, all divided by 3. So 9 pi over 2, and then I'm going to multiply by the reciprocal. The 9 and the 3 reduce to 3 pi over 2. 3 pi over 2. So 3 pi over 2 is right here at 270. Sine divided by cosine would create something that's undefined. 0 can't be on the bottom. And even if it's undefined, you take it times -2, you still have undefined. So hopefully you can see what's happened. Instead of when we looked at the last 3 that we did, the value in front was always positive. So +1, +4, +1. And notice from left to right how it went up. Left to right how it went up. Now it rose at a quicker pace if the number in front was different than 1. If it was greater than 1, it's going to rise at a quicker pace. Just like if this number in front is less than 1. So between 0 and 1, it's going to rise at a much slower rate. So we would, if this was like 1/4, for instance, we would expect it to rise like this, right? It'd be very flat or compressed. All right, let's come over here, and now let's just continue this pattern. So I'm going to go through and continue this pattern for us, and I'm just going to speak out loud as I go. So I'm going to come up, it gets closer and closer to that vertical asymptote, comes through and gets closer and closer. And I'm just going to continue that pattern, gets closer and closer, and continues. It gets closer and closer and continues. And gets closer and closer. All right, so here we have it. This is y equals -2 tangent of x divided by 3. I would like you to press pause, and I'd like you to try this function, y equals -3/2, which is the same as -1.5 tangent of 2 pi x. Press pause, try it, and then come back to this. Let's get started. Let's see how well you performed on this problem. This is not easy. Okay, so the first thing I'm going to do is I'm going to figure out what is the period length. I'm going to take pi and then divide it by the value directly in front of the x, known as the b value. So the pi's are going to simplify to 1, and I'm not left with 2, I'm left with 1 over 2. So the period length, or 4 steps to the right of the origin, will be 1/2. 1, 2, 3, 4. This will be 1/2. Now, how do I figure out, there's not a pi on there, by the way, the pi's have already been simplified. In your mind, you may think of them as being canceled out. How do I figure out what the x scale is? We know that there's 4 steps to both sine, cosine, and tangent to any periodic function, and so I'm going to take whatever my period length is, and I'm going to divide it by 4, which is the same as multiplying by 1/4, and I end up with 1/8. You can grab your calculator. I'm not going to waste your time in continuing to do this over and over, but the thought process here is I want to actually show you a couple different ways to do this. And maybe this will speed it up for you. So I want to go 2 steps over. I know every step is 1/8. Just watch this. So I'm going to go 2 times 1/8. Whoa, I forgot the division sign. 2 times 1/8, math fraction. This is 1/4. I want 3 times 1/8, and maybe you can just see that in your head. And we get 3/8. Now when I hit 4, the 4th step over, I better end up with 1/2, which I do. And we have 5 times 1/8, and we reduce it down. We have 6 times 1/8, and most of you can just start to do this in your head, but if not, I want to demonstrate how to do it. We have 7 times 1/8, and then 8 over 8, which is 1. So it's 1/2 or 0.5 to do 4 steps or 4 units to the right. And if we do 2 cycles, 1/2 and 1/2 equals 1. Going to the right, I have -1/8, -1/4, -3/8, and -1/2. So I've taken care of the period. Notice that there's no number behind here, but when we get to the next example, there will be. So we will practice this vertical shift idea. What are we going to do next? So I'm going to make sure that I have this by me, and I'm going to push up so I have a little bit of space to show my work down here. If I can just push up here. Knowing that my equation is y equals -3/2 or -1.5 times the tangent of 2 pi times, so let's put in 1/8. So I input it in the first step, and then I'm going to simplify this part. So 2 times 1 is 2. And 2 divided by 8, if you're a visual learner, 2 divided by 8 reduces to 1/4. So I want to look and find out what is the tangent at 1/4 pi. This is where 1/4 pi is, or pi over 4. What is the tangent? They're exactly the same. So sine divided by cosine is 1. I have 1, but hold up here. Just because this portion equals 1, I still need to take it times the -1/2 out front, or -3/2, the same thing as -1.5. So 1 times -1.5 is -1.5. My first step, I want to drop down -1.5. Let's go into the second one. Again, just to demonstrate, I have y equals -1.5 times tangent of 2 pi. Now in that place, I'm going to write down 1/4. And this is what I'm going to reduce. 2 times 1 is 2 over 4. That reduces to 1 pi over 2. So I want to look at 1 pi over 2. Here's 1 pi over 2. The tangent is sine divided by cosine. 1 divided by 0. Can't have 0 on the bottom, so it's going to be undefined. And so undefined times any value is still undefined. So I'm going to grab my marker. If you're doing this, make sure it is a dotted line. You're going to catch on to this pattern, right? So let's go and do a few more here. So we have -1.5, tangent of 2 pi, and now I'm going to take it times 3/8. So 2 times 3 is 6. And 6 divided by 8 reduced is 3/4. Notice I'm going, there's 45, another 45, another 45. Hope you're catching on to that pattern. So sine divided by cosine, they're exactly the same values, just one's positive, one's negative. So when I divide them, I end up with -1. If this equates to -1 times -1.5. If you're a visual learner, -1 times -1.5 would be a positive 1.5 or a positive 3/2. So at this position, I'm going to go up to positive 1.5. Let's do 1/2. I can make room down here where you can see it. Y equals -1.5, tangent of 2 pi, and now I'm going to drop in the 1/2. We can see the 2 on top and the 2 on the bottom are going to reduce. And again, like I just said to you, we're going in quarters here. So I did 45 and we evaluated. I did 45, we evaluated, it was undefined. I did 45 and we evaluate. And now I'm here. So we can just continue that pattern. Sine divided by cosine, 0 divided by a number is going to be 0. And taking 0 times -1.5 is still 0. All right, let's speed this up. So if we're going in 45s, I've done 1 step, 2 step, 3 step, 4 step. Here's my 5th step. At 5 pi over 4, that's what it would reduce to. When I figure out the tangent, I'd have +1. But +1 times -1.5, +1 times -1.5 would give me a -1.5. And we can see what this is looking like, right? I already know based on this pattern that when I do one more for you, so I'm doing one more movement of 45. At this position, when I figure out what the tangent is, -1 divided by 0, can't have 0 in the denominator, would be undefined. And undefined times -1.5 is still undefined. That's why I have that vertical line. So I'm going to continue this pattern here of 1.5 and 0. It's getting closer and closer to the vertical asymptote. Okay, hopefully that makes sense. Now we're going to add in one more aspect. What happens when we have a number behind? And I want to see how well you can do. So I'm going to do this one on the back side where I have a little more space to show work. And I would like to see you first try this based on all the information you've learned as we went over 2 of the 3 primary functions in a different video, sine and cosine. What do we do now when we have a -2 in the back? Press pause, complete this, and then come back to the video. Let's get started. So y equals 7/2, which is 3.5, the tangent of pi x minus 2. So the first thing I do is, compared to the first 5 examples before this, we never had a value that was behind it. So I know that there is going to be a vertical shift. So I'm going to drop down. My new line here is I'm dropping down. And this is going to be y equals, this is that midline, y equals -2. And now I can kind of forget about this, right? I've taken care of that shift and I don't need to worry about it anymore. Let's go ahead and let's now identify what is the period for this function. So how do I go about doing that? I'm going to do my work up here where I have a little more space. I'm going to take pi and divide it by whatever's directly in front. Well, pi divided by pi, since the b value is pi, pi divided by pi is 1. That means after 4 steps or 4 units, 1, 2, 3, 4, I'm at 1. And I'm supposed to do 2 cycles to the right and 1 cycle to the left. So if 1 cycle is a length of 1, 2 cycles would be at 2 and at -1. The x scale is going to be whatever the length of the period is, and we're going to divide it by 4. So that's going to be 1 over 4. There is no pi's. Notice the pi's have been, if you want to think of eliminated, they've been simplified into 1. And now I'm going through and I'm just going to add this up. So again, I want to demonstrate a couple different ways you can do this. One way you can do this is grabbing that calculator, my second step, and I'm taking it and then I'm simplifying it. And we can see we get 1/2. And my third step, and I'm taking it times the x scale, and I'm simplifying it right away. And I'm going to keep going here. So this is going to be 5/4, 3/2, 7/4, and 2, and now directly to the right. Okay, it's time. So I've got everything set up. We're ready to graph. Okay, hopefully these patterns are making sense to you right now. Let's start by plugging in the first x scale. So I have 7/2 times the tangent of pi, and then I put in a parenthesis here. I don't need to worry about the -2. We've already adjusted for that on the graph. Think of this as my x-axis right now. I've adjusted that. I'm going to put in the very first x scale value, or the first unit to the right of the origin, which is 1/2, and then I'm going to simplify. So 1 times pi is pi. So I want to go to pi over 4. Notice that that's a reoccurring pattern. I want to go to pi over 4, and I want to evaluate the tangent at pi over 4. Pi over 4 tangent, they're exact same values, so sine divided by cosine is 1. So this equates to 1, but then I have to take it times the 7/2, or 3.5. 1 times 3.5 is 3.5. Where do I mark this? So I went over 1, but think of this as my new x-axis. I went over 1. It's a positive 7/2 or a positive 3/2. Or, excuse me, it's a positive 3.5 or a positive 7/2. So 1, 2, 3, there's 3.5. So this is my mark. I did not want that to be shown. Sorry. We're going to X that out. All right, let's do 1/2 next. Same concept. I have 7/2, taking times the tangent of pi, and now I'm going to take it times 1/2. And you can see, hopefully you recognize the pattern. We're going by 45s. So I just went to pi over 4, and now I'm up here. Sine divided by cosine is going to be undefined, and that's why we had this dotted line here. Let's do 3/2, and then we're just going to continue the pattern. 7/2 times the tangent of pi times 3/4. I get 3 pi over 4, and now hopefully you recognize I'm going by these 45s. So at this third step, I have the same value but different signs. That equates to a -1. -1 times a positive 3.5 would give me a -3.5. So from this position, I want to drop down 3.5. 1, 2, 3, and dropping down 3.5 should be right here. Okay, let's do 1. So if you follow the pattern, this was step 1, step 2, step 3. Guess where step 4 is going to be? It's going to be right here. Sine divided by cosine, well, 0 divided by -1 is 0. And I can take 0 times the 7/2 and still get 0. So I'm going to go on my new x-axis and make that point. All right, my next point is going to be here. Again, I'm going by 45s, 45, 45, 45, 45. So down here, I have the exact same values. And when I take the sine divided by the cosine, I end up with a +1. +1 times 7/2 is going to be that 7/2, or 3.5 above my new midline. And you can see this is exactly what we're getting here. The same pattern here, the exact same pattern. So 1, 2, 3, 4. Make sure you're putting your dots in so that I can see exactly what your thought process is to all of this. All right, so it's looking like this. And it would be down, right? And coming up. Going up here. So it's rising very, very quickly. It's rising very, very quickly. And it would continue to go like this.